There is a fascinating article from NASA about the early universe and how it actually evolved. And the way we look at it now is not the same way you looked at it, maybe I would say 9 million years or 900 million years after the Big Bang. And this particular theory here was actually proven using James Webb Telescope, which is really fascinating based on various interesting properties of the early galaxies and how they are forming stars, and this impacts its environment, which results in the visuals not really that clear or not really transparent. And so having an opaque view of the universe way back before a particular term known as reionization is really fascinating. And now you might be wondering, what is reionization era? This era is when back then, in around 900 million years after Big Bang, there were galaxies that were really young, that had the gases around it to be really compact in such a way that there was not that much ionization of those gases. But as time went on, as those galaxies began to form new stars, this results in those stars emitting energy that results in the gases around these regions to ionize, and so the ionization of such gases results in the expansion of those surrounding spaces around these galaxies. Therefore, this expansion of the gases that are ionized results in a process where you can now see clearly these galaxies. And not only is this happening in one particular location, but it's also happening in many different galaxies location, which causes a merging of these particular gas bubbles that makes us to now have a clearer visual of the universe compared to how the universe was like before this reionization period, which is known to be more opaque. And this article gives data in collaboration between James Webb Telescope near infrared results and Lily's team. And so based on this article here, it says that by analyzing new observations from NASA's James Webb Telescope, a team led by Simon Lilly in ETH Zurich in New Zealand found evidence that galaxies that existed 900 million years after the Big Bang ionized the galaxies around them, caused it to become transparent. They also used Webb to precisely measure the gas around the galaxies, identifying that bubbles of ionized gas have a 2 million light years radius around the tiny galaxies. Now, over the next 100 million years, the bubbles grew larger and larger, eventually merging and causing the entire universe to become clear. Now, a little bit more details about the era of reionization. This here is when, according to this article, that when the universe underwent dramatic changes during this period, it happened after the Big Bang, where gas in the universe were incredibly hot and dense. Now, over hundreds of millions of years, the gas cooled, then the universe hit, repeat, and the gas again began to be hot and ionized, likely due to the formation of early stars in galaxies, and over millions of years became more transparent. Now, furthermore, in this particular article, it tells us how large the bubble, in this case the gas bubbles, are in comparison to the galaxy, and it gives an illustration where, if we think about the hot air balloon, inside it you have a P that is right at the middle of it. So that is how big to think about those bubbles relative to the galaxy itself. And not only is this shown talking about this particular expansion, but it is shown visually provided by NASA in terms of how stars were formed, galaxies assembled with little bubbles to more of the bubbles expanding due to the galaxies beginning to change the ions or gases around them to then we have area of transformed gas expanded, and then finally a clear universe that we see now. That is the end of the reionization process. Now, this was made possible by capturing this particular process by targeting Webb towards a direction where there is a quasi located over there. And so, in terms of what a quasi is, it is known to be an extremely luminous, active, supermassive black hole that acts like an enormous flashlight. And so, when you think about that, it means that it highlights particular light emissions that is towards us, where some parts of the universe you have a little bit of a thicker view or less transparent view to more transparent view based on those galaxies. And so based on those results where light are either absorbed or transparently passing through, that can give you a little bit of an insight into what is happening here. And what they found was really fascinating. And this was made possible by collaborating James Webb Telescope data with that, according to this article, with the observations of the central quasi from the W.M. Keck Observatory in Hawaii and the European Southern Observatory Very Large Telescope and the Magellan Telescope in Las Caponeras Observatory, that is both in Chile. Now, another analogy that this article provided based on the transparency, which is around 2 million light years in radius, is something known as where it is approximately the same distance as the space between our Milky Way and our nearest neighbor galaxy, which is known as the Andromeda. Now, finally, this particular article provides 6 incredible images of the galaxies that are really old galaxies, around 900 million years after the Big Bang. And this here, according to the description, says that NASA James Webb Telescope has returned extraordinary detailed near-infrared images of galaxies that existed when the universe was only 900 million years old, including never before seen structures. And these structures here show some interesting features here, that these distant galaxies are some of them clumpy, and often some of them are elongated and are actively forming stars. Now, there's some little bit of like hesitation in terms of where are the actual sizes of these galaxies. Is it due to gravitational lensing? We don't really know too much about these, but more analysis will be provided in the future. And so it's really incredible to see this here, and how James Webb is not only able to provide such results here, but also how they combine power with it and other collaborations enables us to see this particular and understand this particular phenomenon here when it comes to how galaxies are visually revealing compared to how they were before the era of reionization. Now, this technique here is known as emission line galaxies and intergalactic gas in the epoch of reionization, which is abbreviated to be EGER, and this has demonstrated the unique power of combining conventional images from James Webb's near-infrared cameras with data from same instruments wide field stillness spectroscopy mode that gives a spectrum of every object in this image. So wonderful to see this stuff right here. I hope you found this really informative. Please hit a comment down below. Let me hear your thought about this particular article, and if you want to read more about this, you can find it in the description box. And see you all on the next one. All the same, stay smart as always and believe in yourselves.